Hi, welcome to online tutorial videos from JCBRO Labs. For more information, you can visit us at www.jcbrolabs.org. You can also download the source code of the corresponding video uh, in the tutorial sections from that website. In this particular video, we will talk about how to generate a PWM signal of a specific frequency and with varying duty cycle in Matlab, because generally it is required to do some simulations using PWM signals. So open Matlab. uh, because PWM is it is a kind of signal whose frequency is fixed and the on time period and off time period keeps on varying. So if we talk about suppose if we are varying on time period, so ultimately it's duty cycle, which is on time period upon total time period, which is varying. So first we need to generate first we will generate a square wave, then we will change the on time period of that particular wave. So first of all, we need to define the signal frequency of the signal. Suppose let's say we are generating a 10 hertz signal, and then we will define the sampling frequency. Let's say sampling frequency is 1000. Sampling frequency is higher in order to make the resolution is good enough. Otherwise, it will take the 100 samples per second, so the resolution or the wave representation will not be that much good. Now time, for how much duration we want to generate. So let's say we want to generate a signal of 1.5 second, and then period of 0 to 1 by fs to t. So this t n is the time base over which we will generate our signals. So first we will count how many cycles will be there in 1.5 second of the 10 hertz signal. So number of cycles, we can write it like number of cycles will be simply the frequency and the time. So there will be total 15 cycles in 1.5 second duration. Now let's generate a sequence of ones of length n. As we said, length is the total time axis for the signal. So for the same number of length, we want to generate number of ones there. So x will be of the same length, and let's define a duty cycle. Let's say we have a duty cycle of 50, because this needs to be varied in order to vary the on time period of the signal. Now we will calculate number of how many number of samples will be there in single period. Okay, because we will focus on a single period. As suppose there are 10 number of samples are there in single period, then for 50% duty cycle 5 samples should be 1 and 5 samples should be 0. So we need to identify how many samples will be there in 1 second. So depending on that, according to the duty cycle, we will change that much of samples to 0 or 1. Suppose duty cycle is 2 and there are 10 number of samples are there in single period, so 2 samples will be on and remaining 8 samples will be off, and that will make a 20% duty cycle. And that is why we have taken a large number of samples, because if we have only 10 samples there, and if we say suppose in one period, and if we say we want a duty cycle of 2%, so it comes out to be 0.2 samples needs to be 1. So that will not be possible in that case. So that is why we are taking the higher resolution, so that suppose for 10 hertz frequency we could have 100 samples. So if we say if we are saying we have a 2% duty cycle, so 2 samples will be on, and that could be feasible. So that's what we say, like by increasing the number of samples between in one period, we will be ultimately increasing the resolution of the signal. So that is why this sampling frequency and this frequency matters a lot while doing a simulation, while generating a wave on digital systems. Now we will check how many number of samples are there in 1 second. So it is represented OC by SAMP. That will be simply sampling frequency divided by signal frequency. So there will be 100 samples in one period, and that is pretty obvious. If we are generating a 10 hertz 10 hertz frequency and 1001 kilohertz is the sampling frequency, so obviously there will be 100 samples in 1 second. Then we will find number of samples for on time period, and that will be total samples into duty cycle divided by 100, as we discussed. So for 50% duty cycles, 50 samples will be on. Similarly, off samples will be simple, total number of samples minus on samples, that will be off samples. So 50% duty cycle, off sample and on samples will be same. Now what we'll do, because we have generated a sequence of ones, so we will move in a loop, and for a single period we will make 50 samples on which are already 1. We will make remaining 50 samples 0. That means whatever the off samples length is there, that much of samples will become 0 in a single period, so in a single cycle. So in order to make a complete wave, iteration should go from 1 to number of cycles. So as number of cycles could be, suppose we want to generate a signal frequency of 1.5 samples, 1.5 second. So in that case, or the signal frequency is suppose 8. So in that case, the discrete number of cycles within 1.5 second duration may not be an integer number. So that is why we need to make this cycles integer, and that is why we will take the upper limit by ceil command of the number of cycles. And let's define a temp value in order to keep track of the things. Then x of, because for if we talk about first time period or first cycle period, that will go from temp plus 1 to number of plus on samples plus 1 to number of cycle times I into OC samples. What it is doing, because x is already 1, so we need to make only 0 there for the off time period, and off time period will be starting from on sample period plus 1 to the total cycle period, and total cycle period will vary based on the number of samples I. So we'll make it 0, and then we'll make temp equals to temp plus on samples, and then we will end it it is OC sample. So we made a mistake. Let's see what variable temp has been made. So it is OC samp, and then okay. So I think our signal has been generated. Let's plot it. N comma by this variable, because there will not be discrete cycles. Suppose there are only 3.5 cycles are coming. So by making ceil, we are generating the signal for 4 cycles, but our time duration is not for according to 4. So we will display only those values which are of the same length of the N. and let's say while limit make it -1 to 1.5. let's plot it, and okay, we'll plot it again. Let's first CLC, and let's make it line weight of 2. So clearly a square waveform has been generated. Now let's see what happens if we change the duty cycles. We already have the code. This script is written based on the same, and let's change the duty cycles of 20, and time period is same, and frequency is 10. Let's make it 10, and let's make it so that is for the 20% duty cycle, and we can have a 2% duty cycle as well. So this signal is for the 2% duty cycle, so let's talk it here. Let's change the signal of 8 Hertz, and then see this is the signal corresponding to 8 Hertz of frequency, and let's make it duty cycle to 20%, and this is the 20% duty cycle with 8 frequency, and it is for the total 1.5 second duration in time period. So by this way you can generate a variable duty cycle PWM wave using Matlab, and let's say more than 75% duty cycle. Yeah, so total time period is up to here. Now on time has been increased and off time has been shorter. So this is how you can generate a PWM signal with varying duty cycle in Matlab, and I hope you have enjoyed the video. If you have any doubts or any query, you can comment down on this video, or you can also share your views from our website as well. So that's it for this video. Thank you.